June 2009, question 5. The curve has a parametric equation x equals 2t plus t squared and y equals 2t squared plus t cubed. Okay, first part. Express dy dx in terms of t and find the gradient of the curve at point 3 minus 9. So first of all we do dx dt, and that gives me to the power down to 1 to the power 2 to the power down 2 to 1 of the power, that's 2 plus 2t, and then differentiate y respect to t, and that will give me to the power down, which is 2 times 2 is 4, to 1 of the power, to the power down, which is 3, to 1 of the power becomes 2. And then we get dy dx using chain rule. Dy dx using chain rule is going to give me dy dt times dt dx. Okay, very important, this chain rule, and it's important that you put this in the exam so the examiner can see exactly what you've done. The t's will cancel out, leaving you dy dx. Okay, so let's carry on. So dy dx is equal to dy dt, which we have here, which is 4t plus 3t squared, multiplied by dt dx. Well, we got dx dt, so I need a reciprocal of that, which is 1 over 2 plus 2t. Okay, and if I put this all over each other, 4t plus 3t squared all over 2 plus 2t, that gives me dy dx. Now the question says express dy dx in terms of t, which we've done, and find the gradient of the curve at the point 3 minus 9. Okay, so that tells me, first of all, I've got the point 3 minus 9, so that's my x and that's my y. Okay, so I've got those points, that gives me x is 3 and y is minus 9. But we know from our parametric equations that x is equal to 2t plus t squared, and that I now need to equal to 3. Okay, so that gives me, if I factorize this, I've got two options. Well, actually I take it to the side, so I've got t squared plus 2t minus 3 equals 0. And if I factorize this, I get t two values, which is going to give me a 3 and a 1. That's going to be positive, that's going to be negative. So t can be either 1 or t can equal minus 3. Now I need to check, because I need to know, well, I know that y is going to give me minus 9, so I need to check which of these values, when I plug it into a parametric equation for t, will give me minus 9. So if I go by saying that I know that y equals 2t squared plus t cubed, if I put in the 1 in there, I know that that will give me 2, that will give me 1, that will give me 3. So it can't be that. So I'm going to just double check it is minus 3. So if I put t equals minus 3, I'll get t minus 3 squared plus minus 3 cubed, so that will give me minus 3 times minus 3 is 9, double 9 is 18, that's going to be minus 3 times minus 3 times minus 3 is minus 27, and 18 take away 27 is going to give me minus 9, so t at this point is minus 3. Now I found the value that t is minus 3, and now then can go back to answer the question. Dy dx, the gradient at that point is going to be, when I sub in 4, I'm going to change t for minus 3, and that's going to be 3 minus 3 squared all over I'll get 2 plus 2 minus 3, so that will give me minus 12. Minus 3 squared is 9, times 3 is 27, positive 27, all over. That's going to give me minus 8 plus the 2 is going to give me minus 6. That plus that, well, just taken away, so that's going to be 1715 over minus 6. The gradient's going to be, take 2 into there, so it's going to be minus 2.5. Okay, because that would have been 2, that would have been around the 12, that would be 3 over 6, gives me minus 2.5. Okay, so that's the part, that's first part done. Second part, 4 marks. By considering y over x, find the Cartesian equation of the curve, given your answer in the form, in a form not involving fractions. Okay, so we'll go at the second part. It has given me hints there, so I'm going to use that hint. So first one, part 2, I'm going to put y over x, which is 2t squared plus t cubed all over 2t plus t squared. Okay, so I've got that over that is equal to that over that. First of all, I can cancel out t's from here, 1 from there, 1 from there, 1 from there. So that will give me 2t plus t squared over 2 add t. Okay, furthermore, so I've just took a t out of there, and took a t out of there, took a t out of there, t out of there. Furthermore, I can try and see a link here. I can factorize the top, and that gives me, if I take a 2 out, that'll give me, if I take a t out, sorry, that'll give me 2 plus t all over 2 plus t. And as I can see, these will also cancel out. So that just ends up with t. So y over x is just t. Now, I can use any one of the equations now. I'm going to use the more simpler form. I'm just going to use, I know that y over x equals t, and I also know that x equals 2t plus t squared. I'm going to replace the t here with y over x, so let's just do that. Effectively, it's probably better if I write it down underneath. So I can get x equals 2, put in the bracket, and y over x plus y over x. These are being squared, so they're both going to be squared. Now, I'm going to multiply all this side by x squared, because I want no fractions in my answer. So if I times, and I must times everything here by x squared. So x times x squared is going to give me x cubed equals, that'll give me, x will cancel it and give me extra x at the top, so I'll get 2xy, and that will cancel, giving me y squared. So I end up with this function, which has no fractions in it. X cubed equals 2xy plus y squared. Just double checking it doesn't want everything one side. No, all it says is give your answer in a Cartesian form not involving fractions, and that will be adequate. Okay.